Hello and welcome back. So today we're going to go over pyAPP 7 and performance files. So the first thing we're going to do is import pyAPP. Next we're going to define the path to the pyAPP 7 executable. Then we're going to define a path to the performance file of which we want to edit. We're going to load that performance file into memory. We'll set the X range. We'll set the parameter. We're going to instantiate the computation. Save the performance file. We're going to run the computation, retrieve the results, and ultimately display them. So let's go ahead and import the pyAPP 7 module. And from the module, just like the others, we're going to import files, but we're also going to need the performance module. We're going to declare the same exe directory that we did in the previous tutorial. We're going to define an absolute path to our performance file. We'll call it perf path. We're going to create an instance of a performance file by instantiating a performance chart file from the files module. And we're going to use the fromFile class method and pass a perf path to load the file. So now let's go ahead and instantiate the computation. Which we can get from the performance file instance by using the getComputation method. And now we can go ahead and access the X range. By extracting the X1 range table from the results data member. And we're going to go ahead and set up a print statement just so we can see it at runtime. And what we're going to do next is assign the computation results data X1 range table to a NumPy linspace. So we're going to go ahead and import NumPy at the top and assign this to a new linspace. And we're going to go from 40 to 100, and we're going to break that up into 5 elements. So next we're going to set the parameter, and we're just going to copy the same lines we did for the X range, except we're going to sub out the X range print statement to say parameter. And then instead of the X1 range, we're going to be accessing the X2 range. And of course, we're going to change the linspace from 0 to 4000. And we're going to break that up into 17 elements. And that's because if you break 0 to 4000 into 17 elements, it's going to increment by 250 evenly. So now we're going to save this file, and we're going to make a new file path. So I'm going to instantiate perfmod, where I'm going to add a underscore mod to identify the file that I've now created. And then I'm going to utilize the save to file class method to save that file and overwrite any old ones that I had before. So now I'm going to instantiate a variable perf, which is going to be an instance of the performance chart class from the performance module. And this is going to allow us to access the run function, where we can pass it the newly modified file path to our performance file. the index of the variable that you wish to call out specifically is really important, because you're going to use that to find the corresponding data block in the entirety of the results output. To do this, we're going to utilize the getVariableIndex class method and pass it true airspeed and specific range as the arguments. And once we get those indices, we can then loop over all of the lines in the results file to plot the data that we want to see. So we're going to import matplotlib, and we're going to instantiate a chart. And then we're going to create a for loop over the results file, and we're going to utilize the getLineList. This is going to allow us to iterate over each of the performance lines and grab the data we want to see. So the x-axis is going to be true airspeed. So we're going to access true airspeed from the line instance, and then the y-axis is going to be specific range. So we're going to grab the specific range index from that line. And then we're going to add a little bit of formatting to the chart. And notice that the run was successful and all parameters were changed. And the corresponding output. Notice the relatively low fidelity of each line. That's because we set our X range to span only 5 points. So let's go ahead and change that to about 25 and see how it turns out. So clearly the higher fidelity X range had an effect on the chart. There are more points per line, but it didn't necessarily help the line themselves. They're not really smooth. If you wanted to change the density of the lines, that is a parameter change. So you would go in and instead of 17, you would probably do something a little lower, maybe 5, to get the spread that you're looking for. So that's just about going to do it for pyAPP in performance files. I hope I covered everything you guys needed, and I hope you have a good day.